Hello and welcome back to my channel. We are now at lecture 3 where we'll be discussing about what standard electrode potential is, what cell potential is, what is standard cell potential, what is just cell potential, Nernst equation and a lot more. So let's start with this session today. So in the topic today we'll be covering about topics like electrode potential, which we have already got some hint about in the last class. The standard electrode potential, standard electrode potential, and which is represented by E naught. Now just to quickly check, how will you remember what is the electrode we'll take? We'll take reduction or oxidation? We'll take reduction. Very good. We take reduction potential. So you always take standard reduction potential. Yes, standard reduction potential, which you call as SRP. Okay, and this is always data. In the you'll be given an exam. There will be data sheet given to you, which I'll show you how it looks like in some time. Like for example, copper getting reduced to become copper, and that will have an E naught value of, see, copper 2 plus becoming copper plus 0.34 and values like this, for other items. This kind of sheet will be given to you, which contains all the standard reduction potential values. And if it is not standard reduction potential, you need to convert that into standard reduction potential. Otherwise, you'll not get. That's what we will do in our syllabus for JEE, NEET, CBSE. That's what we'll follow. We'll always do questions on the basis of standard reduction potential, right? I hope you got my point. Next, let's see how to find EMF of a cell. EMF of a cell. What cell we are talking about? Of course, galvanic cell. So let's start to understand a few things before we go to this part. Let me take an example of Daniell cell. Daniell cell. What is Daniell cell? Yes, you're right. Zinc sulfate and copper sulfate. This pair is called as Daniell cell. So suppose on the left hand side I have a container, and on the right hand side I have a container. On the left hand side I put zinc sulfate, a colorless solution in which I have dipped zinc metal, and on the right hand side we have copper sulfate solution where we have dipped copper rod, the blue solution. Then we connect it with a voltmeter here so that the voltage difference can be measured, right? Now see, have a look. This part, what will happen? What reaction will take place? We had discussed this in last class also. The zinc solid here, this solid, zinc atoms could become zinc ion, or zinc ion could become zinc metal. Any of these can happen. In this case also, copper can become copper 2 plus, or copper 2 plus can become copper. Let's see what will happen. So that can be compared on the basis of their reduction potentials. So zinc 2 plus zinc has a value of minus 0.76 volt, whereas E naught of copper 2 plus copper, this is given in the, usually given in the question, don't worry, plus 0.34. So tell me, which process will take place? This one, of course. This won't take place. Therefore, this will undergo reduction. So as I told you in the last class, reduction happens at, very good, red cat. So reduction happens at cathode. And what is happening if this part does not undergo oxidation, a reduction, it will undergo oxidation. This part undergoes oxidation, which is the anode. Yes, it's anode. Now, how to find, you just think about it, how to find the EMF of the cell. How much of voltage will be flowing from left side to right side, right side to left side? How much of voltage will be generated? So it would be high minus low. Yeah, high minus low. So EMF of the cell, E cell, can be calculated by the formula E cathode minus E anode. That's it. This is the formula. EMF of a cell can be calculated by the formula E cathode minus E anode. Now, cell can be of two types. Okay, this galvanic cell can be of two types based on finding EMF. It can be two types. Case one, when the cell is standard. Very, very important. When the cell is standard, right? So when the cell is standard, how do we understand the cell is standard? A cell will be standard when you see that the concentration of these, for example, zinc sulfate ion, concentration of copper sulfate ion. Okay, all of these concentration is given as 1 molar. Temperature is 25 degrees Celsius. Pressure, if there is any gas component involved, the pressure of that gas is 1 atm. So if you have all these conditions in the question, the cell is standard. And for that, E naught cell, E cell is no longer E cell, it becomes E naught cell. At that time, this formula becomes E naught cell, and that is equals to E naught cathode minus E naught anode. See, this becomes the formula. If the cell is standard, only then this is the formula. What if the cell is not standard? So case 2, when the cell is not standard. So when the cell is not standard. So how do you understand the cell is not standard? When the cell is not standard, you can understand it by its concentration value. Concentration value will not be 1 molar. Pressure will not be 1 atm. Temperature could be any temperature, right? It could be any temperature. Okay. Then at that time, can I find E cell just by the formula E naught cell minus E cathode minus E anode? Can I do that? Not really. It won't be correct. Why? Because this is true only when cell is standard, right? So this is I'm telling you this very important concept actually. If you understand this way, you'll never get confused in questions. So this can only be used when the cell is standard. But do we have a standard cell right now? No. The cell given to us is not standard. So for non-standard cells, EMF can be calculated by a potential, cell potential. EMF is not nothing but cell potential. Can be calculated by, can you guess it? Yes, Nernst equation. Can be calculated by Nernst equation. So why do we use Nernst equation? Nernst equation, we study it because not all cells are standard. Some cells have, let's say, 0.01 concentration, 0.02 mole concentration, pressure is 2 atm, 5 atm, temperature is 400, 500 degrees Celsius, anything. That is why we need to know Nernst equation. So why do we use Nernst equation? To find the potential of a cell when the cell is not standard. Now, what is Nernst equation? Please remember the formula. Nernst equation is nothing but E cell. Now see, what's the meaning of E cell? Not standard. See, that's why I did not write the not part here. See, it is not standard. It's a non-standard cell. So I'm finding EMF of a cell, not standard EMF. This is called as standard EMF. This is called as standard cell potential. Why standard? Because everything is at standard condition. This one. But this is not standard. This is just cell potential. So the formula is E cell is equals to E naught cell minus nRT RT by NF log of Q. This is the basic formula. I'll tell you all the terms, don't worry. Now, what is this Q thing? So tell me, this reaction that is happening here for this cell, what are the reactions that takes place? So for this cell, what are the reactions that we have? So here, what are the reactions we have? For this cell, What's the reaction we have? For this cell, the reaction will be, see, the reaction that we'll write for this cell will be zinc solid becoming zinc 2 plus. Why? Because there is oxidation going on, see? Because it's anode. Anode has oxidation. Because electrons are lost, charge is increasing, oxidation. And here, copper 2 plus is gaining 2 electrons to become copper. So see here, the charge is decreasing, plus 2 to 0. It's called as reduction, correct? So these are called as half reactions. Half reaction. Half reaction. The other one is also half reaction. So see, for example, zinc solid is becoming zinc 2 plus. Yeah, this is the equation that happens at cathode. So this is half reaction. Which half? Oxidation half. And this one, you can write state aqueous. And this one is the other half, right? See, now when you add them up, you get 2 electrons cancelled, right? And then you get zinc solid plus copper 2 plus aqueous, see, giving us copper solid plus zinc 2 plus aqueous. Yeah. So for this equation, can you write the Q thing that you have learned in equilibrium chapter, class 11th? Products concentration, which is copper solid into zinc solid, see, divided by reactants concentration, zinc solid by copper 2 plus. Now, in class 11th, you also learned that activity of solids, meaning concentration of solid and concentration of liquid, is always taken as 1. So this becomes, so Q will become zinc 2 plus ion concentration aqueous divided by copper 2 plus ion concentration. So this is Q that we have to put here. Yeah, and what is N? N is the number of electron getting cancelled. So how many electrons are getting cancelled? 2. How many electrons are getting cancelled? 2. So in this case, N will be 2. So this is the Nernst equation. But do we use this for numericals? Not really. Not really. For numericals, this is the formula I will be using. Now, as most of your numericals, most of the questions that you get in exam will be at 298 Kelvin. Okay, don't worry. It will be most, every time it will be 298 Kelvin. You can be rest assured about that. Then Nernst equation gets modified. We have a new Nernst equation. So therefore, Nernst equation becomes, Nernst equation now becomes E cell is equals to E naught cell minus 0.059 by N, because see, this R is a constant, T is 298, F is Faraday, we know that, right? So let me tell you how I got this first, otherwise you'll get some confusion later on. So RT by NF ln Q. Yeah. Now R is a constant. You can take it as 8.314. T is 298. F is Faraday. 96500 Coulomb. Just put it. Just put the value. See? Just put it here. So this part along with the ln part, see, this part along with the ln part will become E naught cell minus 2.303 RT by NF log Q. Now this part this part actually becomes, yeah, you guessed it right. This part will become, see, E cell will now become final formula E naught cell minus 0.059 by n log of what? Q. That's it. This becomes the final formula that I recommend you remember and use it in numericals. This is Nernst equation. This is Nernst equation. So why are we studying Nernst equation? Nernst equation for a non-standard cell. That's it. Because for a standard cell, how to find potential? Very easy. E cathode minus E anode. But here we have to do all this extra stuff. Like E cell equals to E naught cell 0.059 by n log Q, where Q is nothing but product by reactant. Product over reactant. That's it. So with this, we are all set to start with our numericals. So in the next lecture, we'll start with some questions based on the concept we've learned up till now. So far, we have discussed what's what cell is, what's reduction potential, what's oxidation potential, which one we take for numericals, which is reduction potential. We know what is reduction potential actually, what is potential. Then I told you how to find cell potential if both the electrodes are connected. What is cathode, what is anode, where cathode where reduction takes place, where oxidation takes place, right? Now we have basically studied also about how to find E naught cell, how to find E cell, Nernst equation, what is the meaning of the words in the symbols in Nernst equation, what is the meaning of N, what's the meaning of Q, and all these things. So these are the things we discussed today. Now in the next lecture we'll be doing numerical based on this, which many students find difficult, but it's really not. If you understand this way, doing numericals is just a fingertip. It's very easy. You can do it very easily. So for now, that's where we'll stop. So I hope you understood the things we discussed today. And if you're liking this live video, please share it to your friends and do like and subscribe my channel. Thank you so much.